Oh, we got some folks coming in. All right. Real quickly, welcome everyone to our Mastering Kubernetes Resource Management webinar. We're just going to wait a few more minutes to get a few more attendees in, and then we're going to get started at probably 5 minutes past the top of the hour.
So a few minutes equals 2 minutes in this case, sounds like.
That's right. All right, folks, welcome to our webinar. We're going to get started in about a minute, just waiting for a few more folks to join us. Hopefully everyone's had a really great start to their 2024. We're going to have a lot of content to go through today and a lot of exciting conversation around how organizations, customers, folks like yourselves can think about optimizing their resource management in Kubernetes. All right. It is 5 past the top of the hour. We're going to go ahead and go get started. Before we actually jump into the content, just as a matter of housekeeping, we will have a series of polls during the presentation. So please, I encourage everyone to participate. This is a really great opportunity for us to learn a little bit about you guys and interact and really cater the content, or at least the talk track or topics to the things that you care about. So we're going to have a poll, a couple of polls throughout the presentation. So please keep a lookout for that. Another thing that I just want to highlight is that we'll be using the Q&A panel from the webinar itself. So in your Zoom client, you'll have chat, and then you'll also have Q&A. We'll be using the Q&A today. We have somebody that can answer questions as we're presenting. So please, as just to keep things interactive, please don't hesitate. Don't be afraid to use the Q&A panel. So we'll see things there. We'll not be using the chat itself. And then we'll have a dedicated section at the very end where we'll go through a Q&A for anything that you might have seen during the webinar. So with that, let's get started. So welcome everyone to the Mastering Kubernetes Resource Management webinar hosted here at Stormforge. Real quick introductions. My name is Erwin Daria. I'm the Director of Alliances here at Stormforge. I've been here for about 3 years. I live here in the Bay Area in California. My background is in IT. I spent 16 years in the enterprise, mainly working in financial services, private equity, venture capital, and as well as in biotech pharmaceuticals. And then I spent the last 10 years in the B2B technology space, working as an SC or a solutions architect, and then for the last 2 years working in alliances. That's me in a nutshell. Reed?
Yeah, my name is Reed Vandewiel. I'm up in Tacoma, Washington, so same time zone as Irwin, but we're not nearly close enough to actually hang out or do anything like that. I come from a background of about 14 years focused on IT automation. I started my career at a university as a systems administrator for Linux Unix systems. Pretty quickly ended up focusing on kind of an old school technology nowadays, I guess Puppet. People might have heard of it. It's been a long time there. Moved to Stormforge a couple of years ago. And at Stormforge, I have kind of a hybrid bridge role between customer experience engineering, kind of a little bit of sales engineering, but also bridging into our product design team and on the in the engineering side. I couldn't help but put a little comment on Norman Doors there. User experience design is what kind of I get really passionate about, which is mostly don't make me think when it comes to a lot of things in technology. There's a lot that we just don't want to have on our brains.
That's a
Norman
good
Doors,
segue, Reed.
Googleable if you're curious.
I'm going to have to Google that later on. And I think that's an excellent point. we're gonna be covering a lot of concepts that I think are really centered around the giant cognitive load of thinking a lot about minutia and then having how to solve for that. So I think that's an excellent
And with
point
that,
to
let's
make where
dive
you could
into some
explain.
minutia.
Yeah, let's talk about Kubernetes. So before we dive into like the actual stuff, I'd like to start with our first poll. So this is going to be a Slido poll. You're going to see a QR code. Please scan that with your phones and then answer if best you can, as best you can. We'd like to know more about you guys. Like you're joining us. We'd love to know more about your role, and then maybe that'll help us cover specific areas. Maybe spend more time on certain slides versus others. This is all really helpful to us. So if you can please uh, answer the polls. This is great.
Yeah, and Erwin, just for logistics, I assume we have a timer on kind of how long we leave these polls up for typically. Is that like a minute?
Yeah, I'm not gonna have like an actual timer, but let's go until 10 past. We'll do another minute.
Cool. Looks like there's a strong trend already, which I'm not surprised.
No, this is gonna be good. We got a lot of SREs and platform engineers. We're gonna be covering a lot of stuff. And hopefully this is all just very useful to everybody. And I think this will help inform how we spend the beginning part of this webinar. I don't have it down to the second, but we're just going to go for everybody that's just joined us. We have a poll up on the screen. We're going to go till 10 minutes past, and then we'll move on. All
Unless
right.
everybody that joined was on the like a C-suite executive side, though, Erwin, I don't think it's really going to affect the outcome of this particular poll
Yeah,
very
I think we
much.
have an overwhelming majority here, so I really appreciate it. Thanks, everybody. We're going to go ahead and move on from this poll. We still get the results, so if you still have them on a browser, on your phone, or on your laptop, please continue to fill these out, and then these will be really interesting for us. All right, so what are we going to cover today over the next 50 minutes or so? So first and foremost, we're going to do like some baseline level setting introduction to Kubernetes resource management in the sense that we want to kind of really set the table for what we're going to be talking about today. The next thing we're going to be talking about is some advanced concepts. I'm saying advanced here. There's an asterisk here. There's going to be a lot of concepts that everybody understands, but we're going to bring to the surface a lot of some of the considerations you should make when you use some of these more advanced tools or processes when it comes to managing your resource footprint in Kubernetes. We'll end the presentation material with some actual use cases that we have for customers that we've worked with in optimizing their resources, and then we'll have a Q&A at the very end. So really, what we really want to deliver during this webinar is value around just describing some of the different ways of different organizations may choose to optimize for their resource footprint. We're talking about resource management at a very high level, but ultimately what we mean is like the cost for the infrastructure, et cetera. And we'll dive right into that just next. And then obviously we want to make this as interactive as possible. So again, please don't be afraid to use the Q&A if you have a question. Okay, so I think everybody that filled out the first poll, they're all SREs and platform engineers. All of this stuff is going to be very basic to you, and we're gonna run through it real quick. We just want to call out some very specific things. So ultimately, when we talk about resource management, we know that Kubernetes is a container orchestration platform. The smallest unit of management is going to be the pod. We declare the configuration management for the containers within the manifests that drive the pod scheduling, but ultimately as we go from left to right here, what we pay for and the resources that are consumed kind of at the cluster level and at the cloud level, whether we're talking about private or public cloud, is going to be at the node level. So these are the things that we're kind of building, kind of using as building blocks. How do we optimize one so that we can find an optimal capacity for the other? Reed, I don't know if there's anything you want to add here.
Yeah, I think mostly just emphasizing the breakdown is useful because in the industry, there are a lot of fairly mature tools out there that can really help with the node, kind of picking the right kinds of nodes that you're going to put your pods onto. But it's good to remember all the time that the output is only as good as the input. And if you haven't kind of gotten the containers and the pods optimized or well sized or doing good resource management at that level, it's going to constrain the ability of those relatively mature tools on the end of this tool chain to actually cut down on the thing you're paying for, which again is the node.
That's an excellent point.
And or scale it up if it turns out that your workloads are asking more of your nodes than your nodes are capable of delivering right now.
That's exactly right. And then just to dive in more specifically, right? What we really want to focus on, especially at the first half of this webinar, is really focusing on setting requests and limits and how we do that. So for those of you that are on the technical side, this is all very familiar to you. For those of you that are not on the technical side, really these requests and limits are declarative ways that we basically inject values into the manifests that dictate how Kubernetes will spin up these various applications, and then set aside or request or reserve resources at the cluster level so that these applications can actually run. I won't go into too much detail. I don't know, Reed, if there's anything that you wanted to cover here, but I think it's
usually
pretty
the thing to just
self-explanatory.
remind people about at this level is that requests. So we were talking a second ago about like site, you basically determine the size of your containers and your pods, and those inputs go into determining the size of your nodes, how many nodes you need. The only part of this calculus that factors into those operations is requests. That is the size that is used to say this pod is this big, and therefore it needs this many resources when assigned to a node or packed onto a node. The limits are interesting, but all of that is about if there happens to be Slack available. The tools won't plan for it. If there happens to be Slack available, then this container can potentially use up to that much Slack in the event that it has an overage, that it wants to consume more than has actually been allocated for it. But none of that
And in that case,
calculation
you're specifically referring to like limits as they relate to requests, and then that Slack and that burstable capacity.
Right. Basically, requests are the big thing. Limits are kind of limits aren't as important as requests for resource management.
I think of it as
they have
an
a
emergency
purpose.
brake.
Yeah.
They do have a purpose. They do have a purpose. All right. So let's talk a little bit more specifically about how customers address these requests and limits, particularly as they're getting started with Kubernetes, and then how they, if there is a maturity that's like labeled on this journey, which there isn't, like how do you find most customers line up kind of on these three kind of approaches, Reed?
Yeah, and so this, as it's laid out, is just kind of as a company focusing on this, Stormport just talked to a bunch of organizations and people over time. So this is kind of just a pattern that we've seen, which is most people when they start using Kubernetes, resource management, you're aware of it from day one because they introduced that in the very when the second you start learning about Kubernetes, like that's one of the first things you have to understand conceptually. But a lot of people don't necessarily know what to do with it at first, so they either don't set it or just kind of set things ad hoc. And they don't really think hard about it as an ad hoc developer or somebody working on their own cluster until the stuff gets into production. At some point along the maturity kind of journey for an organization, not having resource requests kind of set more, putting more thought into how resources are managed will cause some kind of problem. Oftentimes, this will be some sort of outage. Maybe an application is using it's set to a best effort kind of management, which means no request for any resources, but it's trying to consume them and crashing. Maybe it ran out of memory. Maybe there's not enough CPU available on the node it's allocated to. And some production issue happens. That'll cause people to come back to this problem and say, how do we solve this? Oftentimes, the second way of trying to address this at scale, if you're like a platform management team and just trying to make sure that all the developers are doing something sane, is you might implement some kind of policy that says you have to pick a size. We know that it's not important. You don't want to waste time on it, but just pick a t-shirt size, small, medium, large. How big is your app? And so that often works for a while. Usually what kind of moves an organization kind of to the next level of maturity is, well, it turns out small, medium, large, there's not a lot of finesse in there, and medium and large end up costing a lot of money if every single microservices workload is allocated a medium or large amount of resources. And so there's cost pressure that comes back to say, actually, you got to do better than that. And so then we kind of get to today, the latter stage of management tends to be just more, there's processes in place that force developers or application owners to come back periodically and manually review their resource allocation and their resource management. So it's still a very manual process. Takes a lot of time to get it right. We'll kind of talk later about sort of what it is to set resources correctly. But that's sort of as far as the built-in ecosystem capabilities go right now. And that step three is usually, especially the larger an organization is, the more these costs can add up, and the more quickly that pressure that back pressure gets applied to application owners.
Yeah. Those multiple of seven-figure cost overruns is something that we run into quite a bit, and that cost pressure does come down pretty fast.
Yeah. And this is why. This is the just explaining the why do I care about this piece?
I'd imagine that everyone who's dialed in here has like some focus on one of these bullets here on this slide,
Mhm.
right? So like, why should I care? It's relatively obvious. We want the appropriate management of resources in these cloud native applications because we want to first avoid performance or reliability issues. This is that thing that Rita just mentioned in that step one when everyone's getting started, they're not setting requests, and you run into either contention issues, resource contention issues, or stability issues, etc. Reduced cloud costs is directly related to that second bullet, right? Which is we run into these like maybe phase two kind of solving for everything using a templated approach where everyone's choosing medium, large, and in some cases I've seen extra large. And we ultimately want to mitigate those types of risks as well. And then lastly, I think is again directly related to the third point, which is how do we maximize the ROI? We think about ROI as just a return on investment for the cloud infrastructure that we're buying, but how do we maximize the ROI of the actual engineering overhead that we're putting into these efforts and to these initiatives? How do we make sure that we spend most of our time either transforming existing application portfolio to cloud native, accelerating some of the cloud native adoption without having to kind of circle back and do that manual tuning, that kind of tedious toil that we refer to here at Stormforge. That is the manual tuning process of looking at a bunch of dashboards, making sure, figuring out if you're actually even querying the right data, and then trying to figure out where those values should be, and then obviously integrating them into some kind of process that allows you to continuously right-size the applications as their usage patterns change. Reed, I don't know if there's anything you'd want to add here.
I think mostly just, you already tied it together, Erwin, but that maximize ROI and the noise and manual tasks thing is kind of a direct callback to the current phase three we saw in the previous slide. And it's basically saying, we'd love to not have that. We'd like to get to a more mature state where we're getting sort of like, we're not overpaying for cloud resources, but we're also not spending our time trying to manually manage all of this stuff.
All right, so we're gonna like close out the very basics, kind of part of this webinar by just illustrating some specific scenarios that we've already been talking about, right? So first and foremost, we find that those folks that are maybe in that they could be anywhere in the journey, but this is what we find a lot of over provision workloads where you can see using the illustration on the right hand side, we've got actual usage for a pod. In this case, I'm just using it as an example, and then the CPU requests in this case are set to 5. You have 5 whole cores dedicated to this application, but we know that just using the metrics that it's at 2.4, 2.5 cores, and so everything that delta is wasted resources. These are resources that are reserved by Kubernetes. They are some percentage of a node somewhere that cannot host other workloads, and then that node is something that you're paying for. And so when we find these over provision scenarios, they directly lead to like just cost overruns, really low efficiency. For those of you that are running, platforms of various sizes, I think the quintessential uh, symptom is really high core counts, really high node counts, but then really low utilization. So you'll find in some cases 15, 12, 10% utilization across a really large node count. The second thing, obviously, we want to optimize for, we want to kind of manage around is the under provision workload. So this is those scenarios that Reed might have mentioned at the very early stage of many organizations adopting Kubernetes is when they're not sending requests and you find, or maybe they're sending the requests very low. The pods are starting up. They look like they're stable, but then the load changes, usage changes, and we never really revisit them. And we never really right size them. And then so all these pods run the risk of contention on the node, depending on the node they're on. etc. And so we have all these performance and performance and availability risks in
And this,
these
of
types of
course,
scenarios.
and what the risks are depends on basically how limits are set. That thing I said wasn't important because if there aren't limits or limits are high, you can potentially burst over if there's capacity. But if limits are actually set like at request, if it's a guaranteed quality of service pod, then if the utilization hits that line, it's either going to get throttled flatline until it doesn't need their work anymore for CPU, or it's going to crash, run out of memory.
Exactly.
But either way,
And,
it's a performance reliability issue.
and then just one, you reminded me, a lot of the visual examples that we use, we're going to be talking about CPU. All of these things also apply to memory with the, I think, very specific kind of added risk that when we run out of memory, if there's a limit somewhere, you will crash that pod. All right, so with that, we come to our second poll, and we want to know how you guys set your requests and limits. And so I'm going to put this up, and let's see how everybody fares on this one. I'm always interested to see how these things fill out, because we find there's a wide variety of how folks set them, and then
Yeah,
go
especially
ahead, Reed. I
given
don't know
that
if there's
there's a
something you
lot
want to add.
of SREs and platform engineers on this particular call. I'm kind of curious to see how you guys see
Yeah.
that in your organizations.
We'll let this go until 25 after. So for those of you that are joining us, please don't be afraid to participate. We want to know these things, and then we want to basically tailor how we talk about the rest of the slides that you're going to see based on what these answers might be. I think the SREs and platform engineers are going to win again.
It's interesting. A lot of the times when we talk to organizations, we see a pretty even mix actually of developers and platform engineers. So I wonder if there's it kind of makes me think that given there's a lot of people on the platform engineering side who have come to this webinar, if the fact that they are the people setting them as part of the higher level of interest in the problem space.
I feel like we
Kind of
got
like the people who are doing the work are the most motivated to explore it more.
So the I don't know how many answers this is, but the what are requests and limits is making me feel like we need to go back. I'm kidding. We're not going to go back, but we have lots of content available on our website, stormforge.io, where we go really deep into the answers or what those requests and limits are.
Yeah.
And obviously this is going to be recorded and
I will
available
say
for playback
I will
later
say
on.
too, Erwin, like if I was working for an organization where even if I knew what requests and limits are, but my organization, if I didn't feel good about my organization's policy for managing them, like I see that as a tongue-in-cheek answer that says, like, we know this is an issue, but we don't have a good policy as an organization for how to manage this. Or just
100%,
people don't
100%.
do it because, yeah.
All right, we're at 25 after, so thank you guys for participating and giving us your answers. Again, I'll mention that it sounds like the SREs and platform engineers are ruling the roost here on this webinar. So let's talk about like some high level. We're going to say advanced concepts, but I think what you'll find is that every single one of the things that we describe, we really could dive really deep into the weeds for each one of these. I think given the time that we have, we want to cover them, but we may not cover them to the depth that maybe some of you might want. But I also would use this as an opportunity to encourage everyone to please put questions into the Q&A, and we'd be more than happy to either visit them, or we also have some StormForge folks that are watching the Q&A panel and can answer the questions separately from what Reed and I are presenting
Before you go
on
on,
camera.
Erwin, I want to
Yeah,
make one observation about the kind of the mostly SREs and platform teams are setting the requests in our poll just now. What's really interesting about that is in most organizations, that's separate from the developer role or the application owner role, which means the SRE or the platform team doesn't actually necessarily know a ton about the application. So they can't anticipate necessarily like what are we just looking at, like I know the code, I know the workload, what is it going to be? I can't know that a priori. And so I'm guessing, and definitely let us know if this guess is off course. I'm going to guess that for most of the platform teams, that means that the workflow is I'm watching apps that I might not know much about, and I'm observing their behavior, and that's really most of what I know about them in terms of managing resources for them, is observation based rather than kind of any a priori knowledge about the application.
I'd imagine that to be true. I'd
Yeah.
imagine that observing them, making sure that you have all the appropriate views in your observability tool of choice is critical to these folks being able to intelligently make decision about where those requests and limit values should be set. Okay. The first maybe concept that we want to talk about is the vertical pod autoscaler, or just vertical pod autoscaling, right? So this is the notion that we might have an under-provisioned a pod, maybe one that is where the usage of the CPU, in this case CPU, is higher than the request value. And so what we want to do is we want to mitigate the risk for contention or performance issues, noisy neighbors, things like that. And so what we want to be able to do is vertically change the size of the pod. And so this could be done a bunch of different ways, with everything from just like changing the value in the manifest to updating a series of templates, pushing a bunch of changes to Helm values in a repo somewhere. But the net result is what we want to do is we want to change the amount of CPU that a single container is configured to request against the cluster. Go ahead, Reed.
Yeah, and let me add a little bit. Like, it's what we're talking about with anytime we're talking about autoscaling, we're kind of emphasizing what are we going to change, because a workload, how many resources are assigned to a workload, is kind of a combination of two things. It's what are the individual resource allocations per pod, and how many pods are there, or replicas. And so in a vertical pod autoscaler, in the simplest possible scenario, we're assuming there's a static number of replicas. Often it's one. It could be more than one, but it's a static number in this small context. And we are adjusting how big that pod is, or if there's multiple, those pods all are. Vertically scaling the size of the pods.
Yeah.
Containers, technically.
And then to just close the loop here on this, one of the ways that we can autonomously change the vertical size of a pod is using a very specific tool native to Kubernetes, which is the vertical pod autoscaler. So it is going to pull the metric server for any given object that you want to vertically autoscale, and then use its observation to make a recommendation of what that value should be. And then optionally, you can then implement those changes directly in the cluster. But there could be a lot of challenges here, right? So something to consider when you're vertically changing or changing the vertical scale of your pods is, if they're a single pod application, obviously there are going to be events that are incurred every single time you make the change, potentially. So Kubernetes does not yet have in-pod request changes
We're this close, though,
implemented.
on that one.
I know we're watching it like hawks. But just consider, you have to bring into consideration that when you make these changes today, it's going to cause a rollout or a restart or some kind of disruptive change to the pod. I don't know if there's anything else you want to pick here, Reed, but we can move on to the next way that we find customers handle this kind of right sizing and scaling problem. All right. So the next one is, I think, the more ubiquitous one. This is the one that I think most people use, the horizontal pod autoscaler. So the notion is that we create an HPA object that helps scale a set of pods based on some metric. And for a lot of customers, it's going to be some percentage usage of some resource, whether it be CPU or memory, or in some cases, it might be a custom metric. Maybe they're pulling an external metric store, and they're looking at connection counts, or they're looking at message queue depth. It might be doing a lot of different things, but the notion is that the vertical CPU and memory configuration of the pods should be smaller than the peak usage, and that you'll just add replicas via the HPA to handle the additional load. And then when that load goes away, then those superfluous replicas will then get terminated.
So to compare and contrast HPA with VPA a little bit and just kind of emphasize why it's more ubiquitous, HPA lacks a big downside VPA had, or has traditionally had, which is every time you change those requests, you're potentially going to cause a rollout or restart of a pod. So that's an administration overhead for making a change. HPA doesn't have that as much. Depending on the app, you can still kind of have some things to finagle there. But adding a pod doesn't kill any other pods. The service stays available. Wanted to contrast those a little bit. The other big one is that HPA doesn't have a ceiling, or rather, it doesn't have nearly as close of a ceiling as vertical pod autoscaler does, because a pod can only vertically be scaled so far. Technically, it can be almost as big as the size of a node, but in Kubernetes, that's a very inefficient way to run pods. You want to keep this relatively smaller, and so you're going to run into a ceiling at some point with vertical scaling for a single pod. Whereas with an HPA, you can go from one pod at some set to an arbitrary number of pods, tens or hundreds, even possibly. And so there's not as much of a concern about hitting the limit of your chosen scaling strategy.
That's right. But I think there's a lot of considerations to be made here as well, right? So if you get that vertical size, I'm just going to say wrong. On one side, if it's too small, you can have like replica startup issues. You could have like pod readiness, kind of a mismatch between the spike in the traffic and then the readiness of the actual additional application resources that you might need. And then in
Yeah.
this case, the visual example that we're using here is where you get it wrong on the other side, which is like the actual vertical size is wrong. And so every time you scale a replica, and maybe in this, in this case, we're basically contriving a CPU utilization percentage, an average CPU utilization percentage is kind of the trigger that we're using to scale. Then every single time you add a replica, then it becomes more and more inefficient. It becomes more and more resources requested when it's not necessarily properly representing the actual usage.
I think this
So
the
go ahead.
sum point is that, especially in this illustration, HPA is good. It's better than keeping all those resources up all of the time or allocating them all of the time. But it's visually apparent that there's still some additional kind of optimization we could potentially make in terms of allocating the appropriate number of resources to run this workload. One last comment on the VPA thing I realized I forgot to mention. Some workloads can't be HPA'd. Well, this only works, HPA only works if a workload is built in such a way that it can accommodate multiple instances of the app. Most modern stuff is designed that way. A lot of legacy stuff is not, and a lot of kind of some applications is just not worth the effort. We still see a lot of kind of monolithic applications built today where it doesn't need to have more than one pod. Um, but it can still end up costing a lot of resources if it's handling a large workload, or not need as many if it's handling a small workload.
That's right. Now, the optimal solution, I think conceptually speaking, is having something that addresses both of these dimensions, right? So one, handling the vertical size of the pod, but while also taking into account that you want to scale these like highly variable workloads horizontally, probably, right? So that we're not introducing kind of like a pod restart or taking an application offline in order to change the ability or the bandwidth available for the application to process the load that we have. But while still kind of minimizing what we call slack here at Storeporch, right? The amount of resources that are requested, but then not ultimately used. Now, there's some real challenges here and real considerations to make. Out of the box, HPA and VPA may conflict. So if you're using the same metric, so if we're scaling vertically on average CPU utilization, but we're also scaling horizontally on average CPU utilization, then those two things will result in diametrically opposed behaviors, right? So the VPA will want to keep the vertical size of the pod big enough to keep the utilization at a particular percentage, and then obviously HPA will want enough replicas to try to keep their
Yeah,
utilization
I
at a
think the
certain level.
the main thing to just remember is that if you have both of those things in play at the same time, you can't just change one. You have to remember that the vertical size of the pod will affect the behavior of the horizontal pod auto scaling if it's keying off of something like percentage utilization. Because if you're cutting down the percentage utilization by making each pod smaller, if you don't want the HPA to just scale up more pods to keep the percentage utilization at 50% average, you got to make sure to tell the HPA that. So the two tools, they can be used in conjunction in theory, but they have to work together. You can't just do each in isolation and expect it to shake itself out.
Yeah, and I think this is a pretty common. I think people have seen this before. This kind of complexity um, and this is why we see, I think anecdotally, huge adoption on the HPA side and relatively much less adoption on the vertical pod autoscaler. So obviously, doing it, you can certainly do it. It's really complex to be able to do it. And then I think the other dimension that we have to address is scale. So like it may be really simple, to do this onesie twosie microservice at a time. But for a lot of folks that are managing platforms that represent, if not thousands, if not tens of thousands, or maybe in some cases hundreds of thousands of workloads, this is just something that can be really time consuming is an understatement. This is something obviously an area where there's a lot more intelligent kind of solutions that are available.
Yeah, unless you all are on platform teams that are very different from platform teams I've worked with before, it's a relatively small number of people for a huge number of applications.
That's right. That's right.
There's just not
Pick and
enough
choose
time
if you're.
to hand tune them all on the platform team
Yeah.
side.
It's yeah. I could make like a hipster third wave coffee joke here, but maybe not. All right. So, what are we going to describe in terms of optimal resource management? So, we've talked about some problems that we've had. We've talked about the end user journey of like not setting requests, setting them too high, having to like deal with the toil of manually setting them. We've talked about some tools that are available in the community around vertically and horizontally auto scaling the actual workloads. And we haven't even really addressed the nodes themselves. But when we talk about at StormForge optimal resource management, we're talking about two very specific things. One is right-sizing workloads, which takes into account both the vertical and the horizontal aspects of the scaling mechanisms of those two things. And then as well as using the results of those in terms of the total number of requests. We talked about how important requests are in shaping how we're adding nodes and then bin packing those nodes with pods. So then in this particular section, we're going to be focusing specifically on considerations, techniques, in some ways, solutions to be used when we talk about workload resource right sizing. Okay, so we've seen visualizations like this a lot, but I think just to make it much more direct, what we want to do is we want to resolve the difference between the usage and the CPU requests. So we've already talked about how over or under requesting will lead to performance issues, and when we do that at scale, we end up with this kind of multiplicative inefficiency that then results in those symptoms that we had talked about, which is lots of nodes, lots of CPUs with very low utilization. Some things to consider, and I think we're very pointedly using our GUI here, but like just things to consider when you're looking at a solution or contemplating a solution for vertically right sizing your pods is one, you need to be able to pervasively analyze the resource usage. Whatever the time boundary is for you and your application, whatever is right for that, you want to make sure that you're able to, one, collect the right amount of metrics. You want to be able to query the analysis window sufficient that you get an interesting or a usable or effective amount of usage data, so that then you can then generate right sizing recommendations that then close this gap. So fundamentally, this is kind of like step one in this kind of multi-step journey that will eventually lead to like node optimization and bin packing. But if you don't have these things, if you don't have the capability or the way to do this, then it'll be really challenging to kind of get to the end of this journey. Reed, I don't know if there's anything else that you would want to add here, but like in terms of like other considerations to make, I mean, once you cross this barrier of analyzing every one of your workloads and then being able to generate a recommendation that has a sufficient configuration that you feel comfortable that you can implement it, then you got to figure out different ways to implement it. In this case, I'm showing a Git icon or maybe an actual uh, patch to the API. But you also have to consider things like frequency. How often do you want to right size? What makes sense for your organization? Is it quarterly? Is it monthly? Is it just optimized every time there's a new rollout? Is it hourly in some cases? You got to make considerations for how frequently you want to make those changes. Things like change thresholds are really important, right? So you don't necessarily want to make blindly a change every hour or every day or every week. But if there's maybe an absolute value that you want to use as a threshold, you want to be able to say, hey, if you see more than 10% variance, please go ahead and update, whatever that might be. Maybe absolute values in millicores or megabytes. You want to be able to choose that as well. But that's just something to consider, right? So you might have a process, but if you have a process that continually churns your pods, even when they won't necessarily result in any meaningful or material change in the performance of the application, is something to consider.
Yeah, and I'm gonna.
Go ahead.
Oh, actually, go ahead and finish your one. I'll jump in it
Oh,
when you're done.
I'll just finish this real quick. So like workload compatibility is something that's really important. So Reed has touched on it multiple times. It's not just whether you're doing, deployment, stateful sets, whatever the actual deployment objects that you're managing. Does it have an HPA? Does it have other considerations to make? What type of workload is it? Does it lend itself to the vertically right sizing. I'll hear examples all the time around JVMs where the swap space gets allocated, and then you kind of just have to have it there, and you can't necessarily change those values just out of the box. And then lastly would be scale. So for again, we've been talking about organizations that might have thousands of workloads, tens of thousands of workloads, in some cases hundreds of thousands of workloads. Is this process, whatever solution you choose or are implementing to fix these things, can you do it at that scale? And I think lastly, I would pick on just mentioning the fact that if you're doing these things in cluster, I talk about the VPA a lot. I mean, do you have you considered the amount of compute that will be needed to generate these recommendations in cluster, et cetera? Because those are all going to be things that kind of factor into the trade-offs of what solutions you might use or choose not to use.
Yeah.
But
Erwin, I just want to bring in a comment that we got about that kind of reminds me of a couple of things first. So first off, it's probably good to call out that in this slide, I think you're actually blending a little bit together two things, one of which is how can I know or get a suggestion or a recommendation of like what should requests be for an optimal workload? And this is kind of walking through, by the way, you can automate this or this can be a manual process. Like you just walk through what is it kind of the step of determining what the correct request size for this workload is. But we're also blending in this slide together with great. If we're assuming that if we know what the request should be, that we also want to automatically action that to take that recommendation and adjust it automatically. So we blended two things together. Just wanted to highlight that. The comment we got was on kind of a fourth or kind of a 3.5 stage, possibly on our earlier roadmap, where we say like, people start by not managing it and then they t-shirt size and then they eventually sort of manually tune everything. People do and have built tools to aid them. And so some of the more mature organizations that we've worked with have created varying levels of tooling that will automate bits or parts of this process to varying kind of degrees of sophistication. So one of our current webinar participants mentioned that they've got a chat bot, a Slack bot, that will kind of perform this analysis automatically and raise alerts when something, I'm assuming when something should be adjusted or where there's a new optimal value for requests and or limits. So we've seen some variants of that. We've seen some organizations that have gone as far as to also kind of take that next step that we blended together, which is great. I have a recommendation. How do I automate consumption of that? Although that's a little rare, but just wanted to highlight that we do have a new level of kind of additional sophistication on top of what we described earlier, and also that we're blending two things together here.
Yeah, I think that's an excellent point. It's an excellent point. So I think that this lends itself to our last poll, which is how are you right sizing workloads today? I feel like we're going to have a pretty good. Now we're not asking for specific solutions, but like everyone who's joined us here on this webinar has varying degrees of happiness with what they have in place today, and so would love to hear or see more about where everybody is. I will let this go until 47 minutes after. So we're at 46 right now. Actually, I'll go to 48. I know we're running out of time, but we're gonna be covering node optimization next, and then we'll have a little bit of a Q&A at the very end and then a call to action. And we'll be hopefully sending everybody off with like much more information and maybe not more information, but more things to think about as they embark on their resource optimization journey.
Yeah, the current leaders in the polls, I think, highlight just kind of an interesting moment that we're at in terms of our industry and our technology, which is people have been forced into trying to find some solution to this because it is important.
Yes.
It isn't something that you can ignore. It isn't something you can leave alone. But not a ton of people out there who are totally happy with kind of where they're at. And so there's a lot of I would say organic pressure to find something better, which is, candidly, it's why as a company StormForge exists. We know there's a few competitors that are out there. People are building their own in-house solutions. It's an active problem space.
Absolutely. I think we have a great kind of a sample size here, and so I think this resonates with folks that we talk to on a regular basis, our customers, our prospects, that they do find that either they do have a process, but it could be improved, or they actually don't have one right now and are looking for ways to solve these problems. Again, those polls will continue to be up. We look at those values after the fact. So if you have it already up and you haven't had a chance to answer it, please feel free to go ahead and fill it out. The next section, we're going to focus on the optimal node selection and bin packing problem of this kind of equation, right? So remember that when we started, we talked about like containers, the resource values being set as part of the pod construct, and then eventually leading to nodes. And so we're really figuring out, okay, if an organization has addressed both the vertical and horizontal aspects of their applications, what is the next step in being able to make sure that when we keep those costs, those infrastructure costs in line, and also, how do we maybe introduce some new capabilities that make it a lot more dynamic in terms of its ability to scale. So I'm not going to spend a tremendous amount of time on this, but I think for those of you that are in Kubernetes, you know that traditionally speaking, every one of the cloud providers, whether you're doing an on-prem cloud or you're doing a public cloud, they have the notion of an auto-scaling virtual machine or node group. And so we configure a bunch of these constructs within the cloud service providers that we're using. And then we use cluster autoscaler to then trigger how these nodes get added to each one of these various constructs. But there's a lot of considerations to make when you're building these resource pools, right? So one is, one, understanding enough about the applications and how they're configured to consume the resources is a big one. It leads to picking and choosing different instance types or sizes. So you might have a standard instance size with the 16 vCPUs and 32 or 64 gigs of memory. I see we've got somebody that raised their hand. If you raised your hand, please don't be afraid. Go ahead and put your question into the Q&A panel, and then we can answer it right away. Or if you leave your hand raised, we can call on you in the actual formal Q&A section that we'll have in just a few minutes, and then we can answer your question then. Go ahead, Reed.
Yeah, so actually, based on also some feedback we're seeing in the chat, we might want to adjust this a little bit. So let me outline real quick what this is about, Erwin, then I might actually ask you to accelerate a little bit.
Yep.
For anybody who wasn't aware, cluster autoscaler is a specific named technology rather than just a concept. Cluster autoscaling is a concept. There's a few products out there for. We were going to mention cluster autoscaler as sort of the kind of longest lived existing technology for handling this. We're also going to mention Carpenter as a newer one. I think the net outcome, and Erwin, I'll let you finish those slides and move forwards, though, is there are some pretty good tools out there that largely handle the picking and adjusting nodes that are part of a cluster based on the inputs, which are how many pods you're trying to run and how big those pods are. It's a relatively more mature space than the deciding how big the pod should be in the first place. So the question, though, that I will just bring up on the slide is, so I know we're at 50 minutes and I realize maybe we're running a little longer. We probably should have. The question was, are we going to talk about, yeah, great, we recognize this problem, but is this, do you guys have anything better? Is this a good solution? Can we see what you guys are doing? Unfortunately, we're probably not going to have a ton of time to dig into that, but maybe, Erwin, if we accelerate, we can tease that a little bit at least.
We can totally tease it.
Yeah, we maybe over pivoted on we're just talking about the problem space rather than what we do on our day jobs.
Well, I mean, listen, I think there's definitely a fine line to walk when it comes to like what we do and how we represent ourselves in the industry. We definitely have a solution for the pod autoscaling problem, and we definitely partner with very specific solutions on the node autoscaling piece. And I'll try to wrap up here, and then we can kind of talk mainly more about how we see the problem. And then I think what we want to do is we want to get folks really trying our solution, and we'll talk about what the call to action is at the very end. So here I have a very specific example of a graph that shows total vCPUs for a given environment during a particular scale out event. In this case, we're rolling out a new version of an application. And what you'll find is that Cluster Autoscaler is spinning up new capacity to make room for all the new pods that need to be scheduled. And then as the old pods are terminated, we find that Cluster Autoscaler is serially deprovisioning all the nodes. And you can see that the area under this curve here is all vCPUs that are being paid for, but are not being used, right? So ultimately, the environment gets back to normal, and over the course of a couple hours, we know that it'll return to normal. In this particular case, the technology that was implemented to solve for this problem is something called Carpenter, which is an open source node optimization cluster auto scaling tool. So like Reed mentioned, there's a lot of them out there. Carpenter is the one that For those of you that maybe missed the beginning, I am the director of alliances here. I work deeply with AWS on a lot of different things, and Carpenter is a solution that they committed to the CNCF for this particular problem. Ultimately, what Carpenter is tasked with doing is understanding when you have unschedulable pods because there's not enough capacity, and then pulling from an array of instance types that it has available to it. You can configure those things to then add just-in-time capacity to make that capacity for those unschedulable pods, and then subsequently to be able to understand when you have pods or nodes that are underutilized to find better bin packing patterns that would allow all of the pods to fit onto a either smaller instances or a fewer number of instances. And so the notion here is that Carpenter or other tools that are like it are then constantly actively working on reducing the total footprint of compute capacity that is being used or provisioned for your pods or for your applications. And again, this is the second half of that conundrum, which is if you don't right size the pods in the first place, then the data that Carpenter or any node optimization tool is going to have is ultimately going to be wrong, right? And Reed, I don't know if you want to build on that, but I didn't want to use necessarily
Yeah,
wrong, but maybe suboptimal.
what I actually want to do is just say something about Carpenter. What Carpenter has largely done relative to cluster autoscaler on this slide is Carpenter has iterated enough on the user experience of this problem that for a lot of people that we talk to, they turn Carpenter on, they flip the switch into what one of our engineers here on site, Rafa, has dubbed Safari mode, which basically means Carpenter is given enough leeway to pick whatever instances it wants to perfectly pack the workloads onto the nodes. And it does it well enough that for a lot of people, you can largely set it up and then kind of forget about it. Which is really the end objective of all of this resource management stuff is we would love to define some upfront policies, some basic guardrails, and kind of give some sort of automation system the guidance it needs to do the work for us. Carpenter has gotten real close to that on the node selection and bin packing side of the problem. And there are some other tools out there, but just want to say that's mostly the thing we love about Carpenter is it's gotten real good at that.
Yeah. And then just to draw a finer point on how good Carpenter has become at doing that is Carpenter obviously is a tool that out of the box will work with the EC2 API, but we also have open issues on various cloud providers and that they're integrating Carpenter with their virtual machine API. So Microsoft Azure is one that comes to mind because I'm watching it, but it's sufficiently better at this particular problem than cluster autoscaler that folks are now beginning to implement them into their own solutions. So just revisiting this problem again, I know we've got about 5 minutes left. I want to make sure that we do have some time for Q&A. This is what it looked like before when this particular example, we would do a rollout. We have a bunch of extra capacity. When we implement Carpenter, this is what it looks like. First and foremost, the baseline capacity is optimized, so it fully understands that it can choose from a heterogeneous pool of instance types so that you don't necessarily have to have a cookie cutter approach to scaling. The scale capacity is minimal in this particular case. And then the deprovisioning velocity is really, really fast. So you can deprovision multiple nodes using the consolidation capability. And you can see what the results are in terms of the net result and net savings and total infrastructure, right? So
Yeah.
if you can right size the pods themselves and have something like this handle the node optimization and bin packing, then obviously you're double dipping on the amount of savings that you can get. Go ahead.
Yeah, and we pulled these graphs from our own internal adoption of Carpenter. Like this is the change we saw when we moved from cluster autoscaler to Carpenter during our application rollouts. Erwin, in the interest of time, I actually think maybe we can briefly mention we had a couple of specific kind of generalized customer stories we were going to talk through. But I do want to just key into sort of what we're aiming for with a tool like Stormforge, and then use the rest of our time for Q&A because I think it's more important.
Yep.
We're building towards a Carpenter experience, the experience Carpenter provides in the node selection and bin packing side of that equation, but we're trying to build the same experience in the workload right sizing piece of it, where the objective is to be able to set up some policies, make sure you kind of define the behaviors that you want for your infrastructure, and then largely let the tool handle the work of scaling and right sizing automatically is the target experience. And the way that the way that we do that is basically we lay down a tool like Carpenter on a cluster. that tool will automatically start performing all of that analysis and observation of workloads. And as it gains enough intelligence and information on each workload to start kind of projecting what it's going to need, it'll start automatically sizing those according to some policies that you lay down up front. And those policies are, you can define one generally for the cluster or adjust them per namespace or per workload. And then the last thing I'll say on that, or toss the last slide up. Unfortunately, we don't have time to show it, which would be great if we did. But you can go check it out. There's a sandbox environment if you just want to poke around without installing anything, or if you just want to actually try it on your clusters, there is a free trial. That's answering a question we got in the Q&A. But Erwin, I think if we actually just focus on Q&A, let's actually try and do some engagement before we run out of too much time. And I can go over a little bit if you can. I don't know what
I
your
can totally go over. I can totally go over a little bit. Hopefully our audience is okay going over just a little bit, because I think this is a great topic. I'm going to go back and forth between these slides a little bit, but I'm going to echo what Reed said. For those of you that are interested, now this webinar wasn't designed to be a demo of our solution. We really want to talk about the problem at large at a much higher level. And we want customers to, or prospects or organizations that we work with or don't have a chance to work with, to understand that these things are multidimensional and that they have a lot of options. And what we hope is in something like this, what you see on the screen here, is that you would give us a chance in solving those workload optimization challenges that you might have. So for those of you that are SREs that have also answered that you maybe have a process that's not optimal, or maybe you don't have a process and you need to find one, I would encourage you to sign up for a free trial. We allow our free trials to get a single cluster. We don't care how big it is. It could be anything from a kind cluster to a huge footprint. And from there, all of our documentation and all of our user experience, to Reed's point, will really just kind of lead you through the value proposition of our tool Optimized Live. So again, I don't want to shortchange this, but I also want to very much encourage everybody to take a look at, sign up for a trial if you can. If you can't sign up for a trial, to Reed's point, we also have a sandbox available where you don't have to install any bits. You can just kick the tires on an environment that we've built behind the scenes, and then we can help customers really just kind of see what the capabilities are.
And so, or something that I realize I'm doing this on air live, so maybe I can't fully commit, but it seems pretty obvious to me. Like we should probably just schedule another webinar in the future that does focus on what StormForge does, and we can kind of let people know when that is put together if we do something like that.
100%. So just for everybody that's on the webinar, we will be working on scheduling not only hands-on workshops, which will give everyone an actual hands-on opportunity to instructor-led, either myself or somebody here at StormForge or one of our partners to actually walk you through implementation of the tool. We'll actually go through and go through an actual click through and look at the UI live, but we'll also have opportunities to actually just peer over somebody's shoulder. We'll do some demos, pre-scheduled demos, and look out for those. If we've got your email and we got you on here because you got an email from our marketing department, you'll see those very shortly. All right, I see a couple of questions. I know we're 1 minute over. I think we've got still a few folks that are still hanging on. We've got a few answered Q&A, and then we have a couple of open ones. I see that we've got some folks adding questions in Slido. If you wouldn't mind taking those questions and putting them in here, I would love to answer them. Otherwise, we'll see them in Slido. And then what I'd love to do is put together a follow-up message with our marketing team, and we can answer those questions and send them out to you. If you want to if you want to just email me directly, my name is Erwin. It's just my first name at stormforge.io. And you can ask questions of me directly there. I think, forgive me, Reed, for putting your email address out there, but it's reed@stormforge.io. I don't think I'm breaching any huge like
that
secrets.
Was super hard to guess. I don't know if anybody would have got that if you hadn't said it, Erwin.
Yeah. All right, we got one question. Looks like Yathi is handling it in terms of our support for OpenShift. We do support OpenShift. There's probably a lot more context that is needed, and Yathi will answer that. Again, for those of you that want to hear more about the actual StormForge Optimized Live solution, there's a bunch of different ways that we can do that. A lot of the stuff that's in the slide content here when we talk about broad workload compatibility, the ability to take care of the vertical pod auto scaling along with the horizontal pod auto scaling, the ability to do it at scale at hundreds of thousands of workloads. Those are the things that we do really, really well. And I think we'd be more than happy. You can reach out to me via email or on LinkedIn. You can find me on LinkedIn. Just look at my name, Erwin Daria. Be happy to set up an actual demo, and we can do a real kind of catered demo
All right.
for you and answer your questions directly.
I know we're out of time. I want to inject because one question came up that I just find it fascinating. It's that so there's a comment. Our StormForge's pricing model is based on vCPU per month,
Mhm.
but your product leads to cut vCPU usage. Isn't that is that not an interest conflict? In point of fact, we love that. That's very intentional. The idea is that our aim is to if you're using our product, you should be saving money, which includes saving money on what you spend with us. For most people, or raising it actually if you are one of the few that's primarily under provisioned. But we're very aware of that. We do not consider it a conflict of interest. It is an intentional part of the pricing model.
That is absolutely true. All right, we've you have the audience has given us way more time than we probably originally scheduled, but
Our
we
time
hope that
management wasn't that great. Let's be real.
hey, it's early in the year. We're gonna get better at this. But we want to thank you for joining us today. We hope that you found this content useful and knowledgeable. I like the comment that somebody that was on here was appreciative that it wasn't a commercial or just an advertisement for our solution. And that's what we really want to be able to do. We're going to have a mix of content moving forward throughout the 2024. Some of it will be content like this, and some of it will be much more directly related to, putting hands on or showing you guys our actual solution. And look out for those from our marketing team. But again, I just want to thank everybody for joining us. We really want to continue working with you, and hopefully you guys give us a chance, try out our software, kick the tires on our sandbox, and reach out to us on our social medias, and we'll be happy to engage. Reed, I don't know if you want to add before we sign off.
I think you covered Erwin. I really appreciate everybody's time. Yeah, hope to be able to provide some of the things you were asking questions about in later content. I'm realizing now, just as a result of this engagement, like we always shy away from the commercial stuff. Maybe it's just my background and not being in sales, but there's apparently we should actually do some more of that.
All right, take care, everybody. Really enjoyed it, and we'll see you next time.